afternoon, ladies and gentlemen. I'm John.
I'm David.
And we're going back in time. We're doing a Team Talk. What day is it today? Team Talk Tuesday on a Monday. So David and I used to do this where we used to do a commentary on photographs that I used to take. And, oh gosh, I love those.
Yeah, they were interesting, that's for sure.
There were a lot of photos that, you know, we were just so happy not to be on that project. Oh gosh. So we're going to do that today. We're diving into a photo set. And this photo set is from a job site that I worked on back in 2005, 2006. It's some unspoken multi-story construction in downtown Denver. And let's just call it somewhere between 20 stories and 100 stories.
Okay.
Right?
And we've got one story to tell about it.
We're going to talk one story about it, and this story is about the foundation.
Okay.
Okay. So I worked on the concrete delivery side, and this is, we were replacing the concrete. Mid-December, and most mornings it was 50 to 70 degrees out. And then one morning we got a cold snap. Went down to 10 degrees, and then in the evening it went down to negative 20. And you know, in Denver, the sun doesn't really warm things up very well. So we got a phone call the next morning.
Sorry. Go ahead, John. Excuse me. Here. Okay, go ahead.
So we got a phone call that, hey, some of your concrete hasn't set up, and we're just like, what do you mean the concrete hasn't set up? Of course the concrete's set up. And they're like, no, really. So when we started pulling off the forms, we noticed that the concrete wasn't setting up. So I said, hey, stop what you're doing. Let me come over there with the camera because I want to take pictures of this. Not realizing how much concrete. So this was every continuous spread footing throughout the entire job site. And this was a block and a half by a block and a half. Can you do this?
A lot of concrete.
A lot of concrete. So David, you're seeing the photos right now. You can actually see where the freezing, you know, where the depth of concrete was greater, you know, and like it was trying to stop itself from freezing.
Right.
And then where the freezing just totally.
Oh man.
So we came up to the worst of it. This is the final picture, where, you know, a lot of people ask me, why do we care about cold weather concrete practices? This
is why.
This is what contractors, ready-mix providers, and engineers have bad dreams about. This is 24 hours after the concrete is placed. It had gotten so cold that we just lost that activation energy. And we're going to go more into this in our cold weather concrete week. But
next week.
Next week, thank you. As the residing principal engineer for Intelligent Concrete.
Well, it's not me.
It was not you. This is before you were still working at the Bureau of Reclamation.
Right.
Intelligent Concrete hadn't even been created yet. But if I called David, I'm the field technician, I called my principal engineer from the job site and said, hey David, this is what I've got. Concrete that didn't set up to the point where I pulled forms off at 24 hours, and I have the original slump of when I placed the concrete. What do we do?
Well, for me, it's a lot better to fix it now than when we get up 40 stories. It's kind of hard to fix it then.
Well, at the very least, there's no doubt that I'm glad that this happened right now.
Right.
And I'm glad somebody had the wherewithal to say, something's not right here.
Right.
Because there are a lot of folks that we work with.
Just patch it.
Would dig that out, patch it up, and call it good.
Right.
So first of all, I guess, let's take this step by step. What's the big deal with this? Who cares? Why do we care?
Well, I mean, obviously it didn't set up. I mean, we see it still looks wet. It's still slumping. So it hasn't gained virtually any strength.
There's your steel. There's your steel.
It's steel exposed. Foundations, I mean, they're not massively over-designed normally. I mean, they're designed pretty close to the weight that they're to carry. So if we're losing section, we've got yet another problem.
On image 1167, you see we're losing a significant amount of not just the surface of the concrete, but it's actually exposing the steel. And that's image 1167. On image 1166, every time you see that dark gray concrete, that's where it froze and it fell asleep.
Right.
So if it was localized to one area, is it an easier fix than what we have here in an image? Excuse me, I'm so sorry. Image 1166.
Well, John, a gradient in nature of any kind is bad.
Amen.
High pressure, low pressure, high water level, low water level. I mean, any gradient is bad. Here we've got a gradient in our strength development, and so that's not going to be good.
No.
Part of it's going to want to carry is going to be say, hey, I'm stronger, I'm going to carry more load.
Right.
And it's going to overload.
Right.
And then the weaker is going to say, hey, I can't carry load right now because I'm weak. But eventually it's going to get that load when the other overloads.
Right. So you're going to create some singularities at a certain point.
You're going to create a non-continuous section that's not going to be good.
Especially when we're talking about a 20 to 100 story structure. I don't care which one you're talking about, there's a significant loading and there's a significant chance for a human life loss if something bad goes on.
Well, there's definitely a significant chance of something very bad happening.
Thank you. I think that's a better way of saying it. So,
whether it's financial, whether the parts of the building fall down, or crack up, or that type of thing, or possibly, God forbid, loss of life. So, and in those pictures, John, we're seeing cracks. I mean, that if we think about it as what happens in the lab when we put load on a cylinder and start getting those cracks, then they're well beyond their strength. Their residual strength is minimal compared to their ultimate strength.
The reason why I left this picture, which is 1173, and again, I'm reading this book right now that talks about how in life there are no coincidences. Mm-hmm. And the fact that you just mentioned the cylinder, and I pulled up this column because image 1173 is the top of a column. Now this was a major section. This is when it became problems, that every single column that we had that was meant for the next story, or not the next story, but the next infrastructure for the next story, all of them had the same problem. And you can see how green it is and how it's cracking at the surface. Do you imagine if they pulled this off, patched it? Because to me this is not a patch job. To me this is a rip and replace.
Well, we run hundreds of tests here in the laboratory.
Right.
And the point of testing is we make real life small so we can test it in the lab. But the small becomes large again when we move back out to the field. So if we take a cylinder and we start seeing cracks, can we just putty over the surface and hope for the strength? No.
You can.
You can hope.
Right. But you seriously, listen, as a contractor, it's all about risk management.
Right, true.
And if you could put a patch over it, and if it's strong enough to hold up for 5-10 years, hey, that's hoping, and that hope paid off. So you can do that. As the qualified person on the job site, whatever skill set you're involved with, should you do that?
Well, you and I know in the end it comes down to the engineer of record. So no matter what everybody else says or does or signs or documents, it should stop there.
Should stop. And you as the EOR, as the engineer of record, as the qualified, to use that word very specifically,
right,
as the qualified person on the job site, when it ends there, you say, no. No.
Yeah.
This, to me, and if you didn't know, David is my mentor. He's training me to be a principal engineer, a professional engineer, and when to say no. And to me, if somebody said, hey, this is a quick patch job, right? I'm going back to image. So this is the same thing here. A larger column, and it's green as green can be. This right here, is that a patch job? And so I went from image 1172 to 1171, where you could see how bad that falling asleep was. And to me, this is no longer a patch job.
Yeah, I don't see how you can possibly trust a patch on this, even if you chip all that out and get back to what you think is strong concrete. There's bonding issues, there's, differential strength issues, there's just too many issues. I just don't see this as a high strength patch or any kind of patch.
No, and relying on time to, with concrete, the great thing is, given a certain amount of time, the reaction should take off. But with the job schedule and where it was located, and what every day over the schedule cost, I think it was like every day we were late cost $10,000 from the city, bill from the city. So this, despite the fact that we had to rip and replace it, that was the engineering option, and that was the job site option. One thing is I'm glad to have been on that job site, and I'm glad to have been one of the lead people to figure out what caused that. But I was also glad to be very, very young and have a very low position during this, right?
Right.
I'm on 1171, and this is just...
It's a lesson in disaster.
It's a lesson in disaster, and this is in our lab. Sometimes when we have things that don't work out, I'm the person who makes a decision about throwing out samples and redoing it.
Right.
And do I ever freak out about the samples being lost?
No.
There's
Never.
no sense. Like even when Whitney asked me, "Hey, can I rip and strip those mortar beams?" And I had just done them that morning. I'm like, "Yeah, go ahead." And then she does it. I'm like, "Ah! What did I just say?" When you run into things like this, there's no recovering with concrete.
And you do run into things like this. I mean, things happen. And maybe it's because of the weather sometimes. Maybe it's because of this or that or something else or whatever. I mean, problems happen.
Problems happen.
That's what the on-site people are responsible for, identifying those and rip or replace.
What we did do after this is we ended up using maturity meters throughout.
Right.
And really identifying when that activation energy was dropping. And all right, so we're just wrapping this up here, and it's the why do we care, and I can't tell you which structure this was, and I'm still on photo 1171. But David, after I told you what structure it is and what part of the structure is, why do we care?
Well, John, we've had this discussion before on film for folks.
Right.
We're civil engineers. The civil comes from civics, comes from the same Latin base as for the people. And so it's our responsibility to keep people safe and to do the best that we can for the public. Whether we're in the private sector, the federal sector, the state sector, that responsibility is still the same.
Right.
Is to keep the public safe.
Right.
And so that's why we care. That's our job.
Mm-hmm.
I mean, that's why we're called civil.
Right. And I see the same thing from the opposite side. I remember those ethics classes that we took, the Kansas City or the Hyatt Regency disaster, and
Right.
this disaster. When they asked, can't we just patch this? I thought to myself, I don't want to be involved in the next disaster.
Right. And, knowing about it is enough that you've got to do something.
Right.
Even if you walk off the job, throw your hard hat in the back of the truck and drive off, you still have a responsibility.
Right. Right. Definitely a responsibility. So, with this job site, I'm glad we as a company weren't part of that. But that being said, if we had to deal with that, we would know the harsh answers and the harsh discussion that we would need to have. There's no question.
There's no question.
Right.
There's no question. That's the role of the final signature.
Final stamp. and signature.
Right.
There's literally a slump to the concrete.
Yeah, it's slumping right out of the form. I mean, it hasn't hardened enough to set up enough to stay in the form.
What actually happened was it did harden, but it hardened by freezing.
Right.
And what you're seeing there is they finally dug it out. You know, you could see they dug out from underneath the form because they took the skid loader and they took the snow out.
Right.
And then they let it heat up from the sun. And that, once they pulled the form off, that's when it started.
Right.
I think that's a technical term.
Ah.
The ice melted, and that's when it gained that slump.
I see. Yeah, I thought I was going to look that up. Thanks for explaining that. Yeah.
It's very important. It's French. It's
Oh, I
French.
see. I see.
French. All right, well, thanks for joining us today. Hopefully you learned something. We're actually going to be doing a larger webinar on this, on how to recover for something like this and how to make that decision and why to make that decision.
Right.
And we'll even go into the mechanics and the strain and the stress about that change in cross-section if you did put that load on there and the type of failure you can assume that would occur.
Right.
So we're going to go into this a little bit more deeper. Thanks for joining us today. Go Concrete!
Eat asphalt!